Since I didn't get a chance with the humidity that's in this area, I couldn't just demonstrate a lot of these phenomena. So what I've done is I put two, and this is the same person that's doing these. I thought this is probably the best one I could find online. Different ways to visualize how strong electric fields are that build up this idea of those field lines. You can see things that are streaming away in the direction of those field lines. So if you want to choose one of those or even both of those to look at, great. This simulation right here, though, is one that should give you a chance to play with it a little bit and understand. I've got it pulled up right here. That you've got a blank field, and until you put one of these charges onto the map, you won't create, I mean, there's blank and there's no field there, but as soon as you pull a charge out, okay, you set up a field around it. So I can move that charge around here. You can see what's happening to these field lines that are here. Now, if you want to put a negative charge or another positive charge in here, I can grab this one, for instance, and when I let it go, you'll see what's happening to set up the other fields that are there, the electric field. Now, if you wanted to see, for instance, maybe what the voltage is on some of these, it's going to give you a graphic feel, but you can also grab this tool here and bring it out, and you can see the areas that are potential of whatever charge. So if you wanted to find out, hey, where's 12 volts, if I can stay in 12, I'm getting too much. Okay, there's no place that's 12 in the middle. Let's say I wanted to stay right around where 15 volts were. Okay, I can see there are 15 volts in the middle. It drops off quickly, and there's no other place than 15. But if I want to say where is 10, or 10, like here's 10, and we can find those places where there's only 10 volts. I got to keep doing this. You start to realize that's the area where the voltage doesn't change. That becomes important because if you want to move around someplace without losing energy or causing work, you can stay on the same voltage path, and you can see where that voltage is the same. Now, if you want to put a little sensor to see what that vector is, like how much repulsion there is, this is always the test charge that they put in here is positive, and since we have two positive units, the test charge that they usually talk about is here. And it's always directed, both of these two forces are acting on here, and they're pushing this way. As a matter of fact, if you want to take one of these away, there we go. And that way you can start to see how two positive forces interact with each other. If you want to take this guy away, we can bring it down there and get him away and put a negative on there. You should have a chance to play and see how these two go. What about a plus and a minus? Get closer to these. Okay, I'm really attracted to that one. It's getting smaller. But give yourself a chance to take a look at those. The values themselves, now if I click on that, it'll actually say what's the volts that this is experiencing and what direction that vector goes. So that should start to become familiar because 0 degrees is east, 90 degrees is north, 180 degrees is west. And it just works its way from the x-axis all the way around in terms of saying, well, what that direction of that arrow is. So that gets you used to some of the vectors, and you can see sort of what those experiences are. But it's a great one to return some values. As a matter of fact, you can even do your problems by dropping these on here and measuring out these distances. You have a measuring tape on here if you wanted to check to see if some of your answers are okay. So play with those a little bit before jumping into the next assignment.